We're continuing our Unit 4 polynomial review with question 7 from our review packet, which is asking us to use the remainder theorem to find p of negative 2 for this p of x function, and then to answer the question, is x plus 2 a factor? So the remainder theorem says that if I take my polynomial and divide by my factor, then I will be able to see what would happen if I plug that number in. So if this is my potential factor over here, x plus 2, that's going to be my denominator. I'm going to divide by that and see what my remainder is. Now, if I solve x plus 2, I get x equals negative 2. I set it equal to 0 when I solve, and that's the exact same number they asked me to plug in. So that's the number I'm going to use in my synthetic division, x equals negative 2. So I'll use that in my top left corner for my synthetic division. For my coefficients, I'm going to take a look at my polynomial. First, I'm going to check to make sure I don't need any placeholders. I start with the third power, then I get the second, then I get the first, and here's the 0 power, so I don't need any placeholders. So we'll take the coefficients. 4 for my first term, negative 2 for my second term, 5 for my third term, and 11 for my fourth term. Let's go ahead and do our synthetic division here. We're going to start by bringing down our first term, multiplying it by the top left corner. I'm going to get negative 8. Then we're going to add up and down. That becomes negative 10. I'll multiply that by my top left corner. It becomes a positive 20. When I add up and down, I get 25. That 25 will get multiplied by my top left corner. It will become negative 50. And when I add up and down, I'll get the number negative 39. This tells me the answer to my first question. What is p of negative 2? The remainder theorem says that p of negative 2 equals whatever my remainder was. So it's negative 39. So that part's done. Now my next question is x plus 2 a factor? The answer is no, this is not a factor. And the reason is because I just divided it and I did not get 0 as a remainder. Factors go in evenly with no remainder, and this has a remainder. So it doesn't go in evenly, so it's not a factor. Let's go ahead and take a look at the next question. This says to divide these polynomials using longer synthetic division and watch out for missing terms. So I'm going to go ahead and use synthetic division when dividing as often as possible because it's so easy. Now with these two examples, one of them can be done with synthetic division, and it's example A because my denominator is x plus 2. X in this is just to the first power and it has a leading coefficient of 1. So for this one, I'm going to do synthetic division. When I get to example B, I'm dividing by this, which has 5x minus 4, and the 5 in front of the x eliminates synthetic division from my list of options. I can only use long division to solve this problem. So let's go ahead and take a look at synthetic division for example A. I'm going to set up my problem with coefficients with placeholders for any missing terms. So it starts with a third power. I don't have any second power, so 0x squared, and I don't have any x's either, so 0x. That makes my coefficients 1 for the x cubed, 0 for the squared, 0 for the x, and negative 8 for my constant at the end. The number I'm going to divide by is what I get when I set x plus 2 equal to 0, which is negative 2. So I'll throw a negative 2 in the top left corner. Let's go ahead and divide here. We'll bring down our 1, multiply it by the negative 2 in the top left corner, we get negative 2. Add up and down, still negative 2. We're going to multiply that by the top left corner, we get positive 4, and when we add up and down, it's going to stay a positive 4. Now when I multiply 4 by negative 2, I'm going to get a negative 8, and here, remember, we're adding up and down. These will not cancel. I'll get a negative 16. These four numbers are going to be the coefficients of my final answer, which starts 1 degree lower than the polynomial I started with. So I started with x cubed. I'm going to end up with x squared, and it's going to have a leading coefficient of 1. So I can either write the 1 or keep it invisible. The minus 2 is going to be the coefficient of x to the first power. The 4 is going to be the coefficient of x to the 0, which is my constant. And the minus 16 is going to be my remainder over my original denominator of x plus 2. Now, to avoid confusion, in class I told you can write that remainder, minus 2x plus 4, as plus negative 16 over x plus 2. Both of them I will accept. If you have multiple choice, this is the one that's been more simplified, and it's been simplified correctly. So when you add a negative, and the negative is the only number in your numerator, you can go ahead and just simplify it to a minus sign. All right, for the next problem, let me make the page a little longer because we just decided we needed to use long division. I'm going to go ahead and set up my long division problem. And my page is jumping around. Let's be nice. Thank you. The 5x minus 4 will go on the outside of my long division problem. And on the inside, I'll put my polynomial, assuming that I don't need any placeholders. So I start with 3, then 2, then 1, then 0, so I don't need any placeholders there. So I have 50x cubed plus 10x squared minus 35x minus 7. So let's go ahead and take a peek at dividing here. We are going to start with the term on the left in front and on the left inside, the first two terms. I'm going to ask, what do I have to multiply the outside number 5x by to turn it into 50x cubed? I need a 10 to turn the 5 into a 50, and I need another x squared to multiply by x to make that x cubed. So 10x squared is the missing factor here. Once I have chosen the number to go on top, I'm going to distribute that number to both terms in the front. This is my multiplying step, and I'm going to line them up under my polynomial. So 10x squared times 5x is 50x cubed, just like we wanted. And then 10x squared times negative 4 is minus 40x squared. Now in the next step, I have to subtract, but instead of calling it subtracting, I'm going to call it changing every sign, negative, positive, and now I'm going to add up and down. What I've just done is I've distributed my minus sign, and the only thing that changes when you distribute a minus sign is that all of your operations just change to the opposite. So the positive 50x cubed becomes minus, the one that was already negative becomes positive. Now when we add up and down, my 50x cubes will cancel. I'm not even going to write them there. And then I have 10x squared, and I'm going to add 40x squared, so I'm going to end up with a positive 50x squared in this step. I will bring down my next term, negative 35x, and I'm going to go ahead and do this process again. I'm going to ask myself, what do I have to multiply 5x by to turn it into this number, 50x squared? And again, I'm going to need a 10 to make a 50, and to make x into x squared, I'm going to need an x as well. Now we're going to do our distributing step just like before. 10x times 5x is 50x squared, just like I wanted. And then 10x times negative 4 is negative 40x. Now one more time, we're going to change our signs to the opposite, and then we're just going to add up and down. These 50x squareds will cancel, and here I have negative 35x plus positive 40x, and end up with positive 5x. My last cycle, I'm going to bring down this negative 7, and I'm going to repeat this process one more time. What do I have to multiply 5x by to turn it into 5x? The answer is 1. 1 times 5x is 5x. I should be doing that in green. 1 times 5x is 5x. This is distributing. 1 times negative 4 is negative 4. One more time, we're going to change those signs to their opposite and add up and down. We get nothing for the 5x's. Negative 7 plus 4 is negative 3. I have nothing else to bring down here, and there's no way I can change 5x into negative 3 to begin with, so I'm going to have my final answer, which is consisting of my 10x squared plus 10x plus 1 plus my remainder of negative 3 over what I was dividing by, 5x minus 4. And again, you are welcome to simplify this as minus 3 over 5x minus 4. In this case, that is the proper way to simplify. So for this problem, both of these would be correct. We're going to pick up with factoring in the next video.